All right, today in geometry, we are going to tackle two sections, section 7.1 and 7.2, the Pythagorean theorem and the converse of the Pythagorean theorem. So first we're going to start out with what is a right triangle. A right triangle has one right angle, which is equal to 90 degrees. So in this picture over here, I could put, remember what our 90-degree notation looks like, a right angle. And then it will tell us that the hypotenuse is the side opposite of the right angle. So in this picture, here's my right angle going across. This would be my hypotenuse. The other two sides would be referred to as legs of the triangle. The Pythagorean theorem states in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So in this picture, we would need a right angle down here. And so C would be my hypotenuse. So the Pythagorean theorem says a squared plus b squared equals c squared. And the converse of the Pythagorean theorem. Remember that converse just means that we trade places with the hypothesis and the conclusion. So the converse of the Pythagorean theorem says if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So this one, we start out with, let's see, we can call this A, B, and C. If we know that c squared equals a squared plus b squared, then we could say that the triangle is a right triangle. Let's talk about some theorems next. So we have theorem 7.3. Theorem 7.3 tells me that if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So in this triangle, this is angle A, this would be side A, side B, and side C. So if side C squared is less than a squared plus b squared, then we would say triangle ABC is acute. The next theorem we have would be theorem 7.4. Theorem 7.4 tells me that if the square of the length of the longest side of the triangle is greater than the sum of the squares of the lengths of the other two sides, then that triangle is going to be obtuse. So again, if this is my A, B, and C, so this time if c squared is greater than a squared plus b squared, then triangle ABC is obtuse. In the back, we have what's called a Pythagorean triple. A Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. And I just gave you a table that has some of the most common ones. So we look at the first column, 3, 4, 5, 6, 8, 10, 9, 12, 15, 30, 40, 50. And then notice at the bottom I put 3x, 4x, and 5x because it's just saying any multiples of 3, 4, and 5. So I can notice this is times 2, this is times 3, this one's times 10. So 3 times 2 gave me 6, 4 times 2 is 8, 5 times 2 is 10, 3 times 10, 30, 4 times 10, 40, 5 times 10, 50. So any multiple of 3, 4, and 5, or sorry, any 3, 4, and 5 when they are all multiplied by the same constant. And then we also would have 5, 12, 13. Those three numbers, any of them multiplied again by the same constant, 8, 15, 17, 7, 24, and 25. Those will just save us some time. Instead of having to do the Pythagorean theorem, if we recognize it as a triple, then it saves us a little bit of work to do. All right, so we're going to start out with some examples. It says identify the unknown side as a leg or hypotenuse, then find the unknown length. No decimals. This is why we did all of our radical review. These are where our right angles are. So I notice that the x is not across from the 90, so I know that this is a leg I'm looking for. So we would set this up, x squared plus 3 squared has to equal 5 squared. So I have x squared plus 9 equals 25. Subtract 9 from both sides, so I get x squared is equal to 16. And then take the square root of both sides, so I get x is equal to 4, and again we said that was a leg. In example number 2, the x that I'm looking for this time is across from my 90, my right angle, so I know that we are looking for the hypotenuse. So the Pythagorean theorem here would state 4 squared plus 6 squared equals x squared. 4 squared is 16, 6 squared 36 is equal to x squared. Add 16 and 36 and we get 52 equals x squared. When we take the square root, this time 52 is not a perfect square, so factor tree, 2 and 26. 26 breaks down to 2 and 13, so I have a pair of 2's. So on this one, x is equal to 2 square roots of 13, and again we said it was the hypotenuse. I'm going to look at a word problem next. This tells us that we have a 16-foot ladder resting against the side of the house. So let's go ahead and draw a picture of that. Here's my house. Here's my ladder. They told me that the ladder was 16 feet tall, so this is 16. It is 4 feet away. The base of the ladder is 4 feet away from the house, so from here to here is 4. We've made a right angle. Approximately how high above the ground is the ladder? It wants to know this side right here, which happens to be a leg. So again, Pythagorean theorem would say x squared plus 4 squared equals 16 squared. So x squared plus 16 equals 256. Subtract 16 from both sides, and we get x squared equals 240. Take the square root. This time, notice it said approximately in the word problem. Approximately means I can have a decimal. So here we're going to get x as approximately 15.5 feet away. Or sorry, 15.5 feet above the ground. The next type of problems we're going to look at, it says determine if the segments can make a triangle. If so, classify it as acute, right, or obtuse. So first we want to see, can it make a triangle? And we learned how to do that back in chapter 5, the last chapter that we looked at. Remember that you take the two smallest ones, add them together. If it's greater than the third side, then you know you can get a triangle. So here, I'm going to take 4.3 plus 5.2. Is that greater than 6.1? Yes. So I know I can make a triangle. So now I have to figure out what type is it. That's where we're going to take the two smallest ones, square it. So I'm going to say 4.3 squared plus 5.2 squared. I don't know how that's related to 6.1 squared. So remember, we have the three theorems. We have the Pythagorean theorem that says if these are equal to each other, then it's a right triangle. If the longest side squared is greater than the sum of the other two sides squared, then we know that it's obtuse. If the longest side squared is less than the sum of the other two sides squared, then it's acute. So that's what we're looking for. So that's why I've just kind of put a big circle there. So let's square these. So 4.3 squared gets me 18.49. 5.2 squared gets me 27.04. I don't know how they're related. 6.1 squared is 37.21. Add these two together, so I get 45.53 and 37.21, which is bigger. 45.53 is bigger. Those were the two smaller sides. So my longer side is less than, so therefore here I have an acute triangle. Let's go to number 2, doing the same thing. 15, 20, and 36. So again, first check, can I make a triangle? 15 plus 20, is that greater than 36? 20 plus 15 is 35. That is not greater, so I can't even make a triangle. There's no triangle. Okay? If there's no triangle, then it cannot be acute, right, or obtuse. So we're done with that one. Number 3, I have 24, 30, 6 square roots of 43. Again, I need to know 6 square roots of 43, what is that? Okay, I can type that into my calculator. Or I know that 43 is greater than 36, right? And 36 is 6. The square root of that is 6. 6 times 6 would give me 36. So I know that that's my longer side. So 24 plus 30 greater than 6 square roots of 43, which is about 36. Yes. So I know it's going to make a triangle. So now, again, we do 24 squared plus 30 squared, and we want to know how is that related to 6 square roots of 43 squared. 24 squared gets us 576. 30 squared, 900. Again, this is why we reviewed all of those radicals for so long, because here I have to square both of them. 6 squared is 36. The square root of 43 squared is just 43. 576 plus 900 is 1476. 36 times 43 is 1548. Which one of these is bigger? 1548 is bigger. That was my long side. Therefore, this is an obtuse triangle. Now we're going to look at the last one on this page. 12, 16, and 20. So again, can I make a triangle? 12 plus 16, is that greater than 20? Yes. So I know I can make a triangle. So now I just need to find out what kind. 12 squared plus 16 squared. How does that relate to 20 squared? 12 squared is 144. 16 squared is 256. 20 squared is 400. Add 144 plus 256. I get 400. 400. These two are equal, therefore it is a right triangle. And these are properties that you need to memorize. You need to memorize when they're equal, it's right. When the longest side squared is greater than, then it's obtuse. And when the longest side is less than, then it is acute. So we want to make sure that we memorize those. All right, our last page of notes. It says find the area of an isosceles triangle with the given side lengths. Okay? So let's go ahead and draw this triangle. Isosceles means two of my sides are the same. So I have 13 and 13. This would be my 10. Let's recall the area for the formula for area of a triangle. That's 1/2 base times height. If it's an isosceles triangle, I need to drop my height or my altitude down. This is my h. If I drop an altitude down in an isosceles triangle, I split my base in half. So this is 5 and this is 5. So the first thing I need to do is find my height. Pythagorean theorem. So h squared plus 5 squared equals 13 squared. H squared plus 25 equals 169. H squared equals 144. H equals 12. 5, 12, and 13, does that sound familiar? It should. Over here, right? One of our Pythagorean triples. So again, had I memorized or recognized that was a Pythagorean triple, then we would have saved some time there. So now I know what my height is. So now the formula. So the area is 1/2 my base, the entire base, which was 10, times the height, we just found out to be 12. So half of 10 is 5. 5 times 12 is 60. My units were meters, so square meters. So 60 square meters is the area of that triangle. Let's look at this one over here. So 26, 20, and 26. So my two legs that are the same are 26. Again, I need the height, so I'm going to drop down my altitude. That makes this a 10 and this a 10. This is h that I'm looking for. So I would have h squared plus 10 squared equals 26 squared. Let's go back again. Investigate. I have a 10 and a 26. 26 is my hypotenuse. Oh, look right here. It's another triple. So I see 10, 24, 26. So since we now know that our other side, or sorry, that our height is going to be 24, I don't have to finish that. So here I know that h is 24 because it's a triple. See how that can save us some time. So now I can say my area is 1/2 the base of the entire triangle, which is 20, times the height, which was 24. So half of 20 is 10. 10 times 24 is 240. My units were meters, and again it's squared, so 240 square meters. Okay, let's look at another concept. It says the given lengths are two sides of a right triangle. Find the length of the third side and determine whether it's a leg or a hypotenuse. Okay. These are all going to be a whole number, so it must be a whole number. Whenever we have these types of problems, we must be a whole number. So what we want to do is go ahead and square both of our numbers, right? Because we know that we're dealing with Pythagorean theorem. And so we square our sides. So 20 squared gets me 400. Let's do 25 squared. That is 625. So we're looking for, do we need to add those two sides together? and take the square root of it and get a whole number, or subtract them and take the square root of it and get a whole number. So let's try subtraction first. So if I did 625 minus 400, I get 225. The square root of 225, is that a perfect square? Yes, that's 15. Okay, so that worked. So I know that the third side's length is 15. Now I just have to determine if it's a leg or hypotenuse. Remember, hypotenuse has to be the longest leg. So 20, 25, and 15. 15 is not the biggest, so this is a leg. So let's try that again. 2896, so do 28 squared. So 28 squared gets us 784. 96 squared gets us 9,216. So let's subtract those. 9,216 minus 784. That gets us 8,432. Take the square root of that. Not a perfect square. So we're not subtracting them. So we need to go back and add them. 9,216 plus 784. That gives us 10,000. The square root of 10,000 is a perfect square. That's 100. So I know that the length of my third side is 100. 100 is the biggest number that I have here, so it is a hypotenuse. The last one that we're going to look at, this is find the length of the missing sides. We should have right angle right here as well. So I see that first I need to find y before I can find x. And again, I'm going to do that with Pythagorean theorem. So y squared plus 4 squared equals 4 square roots of 2 quantity squared. So I have y squared plus 16 equals, again, I square both of them. The 4 squared is 16, square root of 2 squared is 2. So I get y squared plus 16 equals 32. Subtract 16, so I get y squared equals 16. Take the square root, y equals 4. So there's the first side. So I know now this is 4. Now I can use that and do Pythagorean theorem on this side. I don't know why I just copied that down there. Do Pythagorean theorem on this side and find x. So now I would have x squared plus 4 squared equals 7 squared. So x squared plus 16 equals 49. Trying to get x by itself, so subtract 16 from both sides. So I get x squared equals 33. Take the square root. That is not a perfect square. And factor tree, nothing's going to come out, right? 11 and 3. So x is the square root of 33, and y was equal to 4. So that is section 7.1 and 7.2, Pythagorean theorem, and the converse of the Pythagorean theorem all mixed together. Your homework today is a 7.1, 7.2 worksheet over everything that we've just talked about.